Hey, what's going on, everyone? Happy Friday. Welcome to TGIK episode 142. Almost to that 150 mark. How's it going, everyone? If you're just joining us, feel free to say hey in chat. It's a bit of tradition to kind of say where you're signing in from if you feel comfortable. We have a pretty big audience from all over the world, so we're super glad to have you. Looks like so far we've got Rory joining from Scotland. It's great to see you, Rory. We've got Haim from Israel. Rupesh. Hey, Rupesh. Noel. Great to see you, Noel. Martin. Great to see you as always from the Netherlands. We have got Mohammed from Paris. Hey, Mohammed. Otome from the Netherlands. Sorry if I messed up your name there. Yeah, I did change my background. It's just a white wall right now. This week's been crazy. I didn't have time to do anything fancy for TGIK. So just looking at a white wall there. Hey, Michael, nice to see you. We got Sevi from Istanbul. Hey, Sevi. Marcin from Poland. Great to have you. All right. Let's see. Great to see everyone signing in here. So, let's just flip my screen over to the desktop. Today's episode, we're going to be talking a little bit about Carvel, which is a really cool tool set that I'm excited to explore. It's something that I'll be using for some projects that we're working on right now at VMware. So I'm kind of excited to learn a bit about some of the tool set with y'all and kind of see what you think and get some feedback and thoughts. Who else we got joining us so far? So we saw Michael, Yusuf from Morocco. Hey, it's nice to see you too. Again, Yusuf. KR from Scotland. Rada from Scotland. Good to see you. Irby from London. We've got Keith from Ireland. Keith signing in from Ireland. Hey, Keith. Daniel from San Jose. Elko from Holland. Wow, cool. We've got a pretty big audience today. Kana, great to see you. I'm glad you're here to learn. We're going to both learn some stuff together for sure. Kokchen in Argentina, Juka, Helsinki, Rupesh from South Africa. Hey, how's it going? We've got Joe hanging out as well before he has to jump for some meeting stuff. Coming in from Seattle, of course. ABC, nice to see you as always. We got Paul from St. Louis, Atish from Canada, Fully Geared Bear, great to see you as always. John Shea, great to see you again. Hey, Nick C. Miller is on my team. So we're working together doing some cool stuff in the Kubernetes space. So great to see you, Nick. Jonas, hey, Jonas, also a person who's in our group. Jonas, great to see you. We got Luis, we've got Nick as well. And I think we might have some folks joining us from the Carvel crew as well. So if anybody from Carvel is here, feel free to say something in chat that you're from the Carvel team, and you'll probably help us out as we play around here and learn a bit about the Carvel tool set. All right, so Carvel, what do we got going on this week? And I guess I'll back up. I'm getting ahead of myself. Let's talk about TGIK in case this is anyone's first TGIK. So in TGIK, what we typically do is we explore some topic, some tool, some concept in the Kubernetes space. As you can tell, this is our 142nd instance of doing that. Today, our topic is Carvel. But before we get into the tool, we like to talk a little bit about what's going on in the Kubernetes ecosystem. This week, the news is light, not necessarily because the news is light, but because Josh didn't have much time to prep. It was a pretty crazy week this week, I'm not going to lie. So if anybody has things that are happening in the Kubernetes ecosystem that you want to add and have us talk about, you're welcome to edit this doc. You can go to tgik.io/notes and add any news items in. But I have a very short update this week. One is that there's been some new Kubernetes releases, so check that out. If you're in 17, 18, 19, 20, or 21 land, I guess if you're testing out 21, there are new releases, so do check those out. Figure out what you're going to do update-wise and get all that pulled together. And the only other thing that I've got this week is Manuel from Ingress Nginx is stepping down, and I wanted to call this one out in particular because back in how long ago was it? It was like Kubernetes 1.4 or something like that. Myself and some coworkers wrote what eventually became the ALB ingress controller, and I think Amazon just calls it, or SIG AWS just calls it like the what is it called now? Someone probably knows in chat. It's like the Amazon or the AWS ingress controller, because it's more like general purpose than ALB now. Nonetheless, what I'm trying to tell you is Manuel was extremely helpful, not only in shaping Ingress over time, but obviously being a huge proponent to Ingress Nginx. I remember when we were writing our controller, he helped do code reviews. He helped us with some of like the core library stuff for Ingress, which I think now most folks are using like controller runtime. But back in the day, I think we actually had like a library called Ingress or something like that. I can't really remember. Nonetheless, he was extremely helpful to us, and I know that a lot of us have been impacted by his work, because who hasn't deployed an Ingress Nginx controller at some point in their Kubernetes history, right? We've all done it. Whether we're running Nginx today or not is another story, but like we've all deployed this thing, and this human has had a big impact. So thanks so much for all your work. I don't know what you're doing next, but best of wishes to you. All right, so let's see what we got going on. Cool. So we have some folks from the Carvel team joining us. Looks like we've got Helen, Aaron. Thanks so much for joining us, folks. Glad to have you in chat. So if you've got some questions as we go through, feel free to ask everybody, and they will be able to jump in and help where needed. We've got Jose from Panama, John from Carvel as well coming out. Thanks so much, John, and Carrie as well. Hey, Scotty, good to see you as always. All right. So let's look a little bit into Carvel. I guess it's good that the news week is light this week. I have a bit of a hard stop at the top of the hour, so we'll get to spend as much time as possible digging into the Carvel toolset. So let's do some framing real quick. Chat, help me out here. We have a lot of tools to do a lot of different things with packaging, with deployment, with lifecycle management of bits in Kubernetes, right? So what do you all use for these types of things? Let me know in chat. Some of you probably use Helm. Maybe some of you are using Carvel. Maybe some of you are using like an Argo CD workflow or something like that to kind of deploy. Let me know in chat. What do you use at your org right now to maybe package apps, or if not package, even deploy them? Just give me kind of your tool set, your stack that you're currently using. Michael says Helm. Kokjen, you said Helm v2. Oh, you're migrating to v3 at the moment. Good. I'm glad you're getting on that. Definitely important to knock that out. Okay, cool. Seeing fully geared bear, Argo CD with JSON at workflow. Cool. Interesting that you got a JSON at workflow going. And Argo CD and some of the other ones are obviously gaining popularity. Flux controller is one I think we've done with Steve Wade, right, back in the day. A lot of these GitOps workflows are emerging and becoming more popular. Seeing some more Flux, GitOps toolkit. Yep, absolutely. Hey, Maddie, cap deploy and cap inspect rock. Awesome. Very cool. Are you using that today, Maddie? And and then Bojancha, you said Pulumi, Helm, Spinnaker. So you've got a pretty diverse stack of things there, like a pure code approach. You've got Helm probably doing templating and lifecycle management to some degree, and then Argo CD probably facilitating the deployments, right? So cool. All right, so let's talk a little bit about the Carvel toolset and what we're going to focus on today. So Carvel has a newish website if you all have not checked it out yet, and I do have it in the show notes, although it's pretty easy to remember. It's just carvel.dev. And I think one of the interesting things about Carvel is that instead of being kind of like a one-size-fits-all tool that does all the things end to end, it kind of breaks the different problems into small chunks and then follows, the kind of do one thing well philosophy to whatever extent that's possible in individualized tools, right? So some of you might remember a TGIK that Joe did a while back. And I think Joe focused on, and I could be wrong, but I think it was YTT and CAP primarily. So when we kind of look at the different problems that we need to solve for, right? One of the problems that we're oftentimes solving for is how do we templatize, parameterize, et cetera, the different manifests and all the things that we're trying to do, right? And then once we've got all those different bits templatized, we also need to figure out how are we going to actually deploy the thing, right? And this is just, I'm making very broad buckets here, right? And kind of including potentially multiple tools in each of these. Of course, even maybe a step before all this, before we worry about like templatizing and parameterizing our manifest that we eventually get into Kube, we've obviously got the need to build, to have kind of a build step in there to some degree. So creating a container image, building probably within our container image with like a build image or something, actually building the binary or the assets that are going to run inside of the application, right? We've got deploy, templatize, and there's a whole other kind of grouping of things that we might care about here, right? We might care about things like, well, how do we take this approach like deploy and how do we do it in a GitOps model, right? Or how do we do it from a CLI and so on? And when we look at these different problem domains, Carvel has tools that let us do all these different pieces, right? Or at least some of these different pieces. YTT is a templating language, right? So that's something that we can go in, we can templatize or parameterize certain fields in the manifest. We can inject values in, all that good stuff. Cap, as we've seen with Joe in the past, is something that's going to enable us to actually deploy and do lifecycle things with packages that we deploy into the cluster as well. Now, what I'm interested in looking at with you all today is specifically kbuild, and image pack, two specific tools in the tool chest that I don't think we've looked at much. And we might talk a little bit about cap controller today, but we'll probably leave that to a future episode where we try to bring kind of all the different pieces together in deploying things intra-cluster. So, be it a GitOps model or otherwise, being able to pick up on our packages, bring them in, run them, all that good stuff. All right. So first thing that we're going to look at is kbuild or KBLD. So what do we got going on here? So one of the kind of interesting things that we think about when we're actually going in and kind of starting off our processes is oftentimes the idea of building images, pushing them, and making sure that they resolve consistently in our environment, right? So let's think about this space a little bit and kind of what this build box might actually do. So the first thing that we probably want to do, right, is we want to go in and we want to let's say create an image, right? So we'll create image here, right? All right, and then we will go in and push the image to a target repo. Push image to repo. All right. And then eventually we probably want to deploy container to K8s or something else. In our case, probably Kubernetes, given that you all are here, right? And when we deploy that container to Kubernetes, what Kubernetes is going to do is it's going to essentially resolve the image that we specify, right? Now, one of the things that we want to kind of look at in each of these different pieces is how we can effectively do each one of these steps, like starting off with creating an image. So, what ways can we create an image? So chat, I'm going to ask you again here. When you build container images, what do you use today? Are you using Docker? Are you using just pure build kit? Are you using why am I blanking on the name? Source to image stuff, S2I if you're in Red Hat land, but build packs is what I was looking for. What do you currently use to create your container images in your environment, right? So I see some Docker with BuildKit, since BuildKit is a first-class citizen in Docker now, right? So that totally makes sense. Bazel and Docker, yep, absolutely. We've got GitLab Runner running Docker, right? Yusuf, you've got Jib, which Jib is going to enable us to do Java-based builds in a really elegant way and allow us to kind of put layers in place in that jar that we eventually create so that we're not always repackaging a full jar. Does some fancy stuff. Joe says we've got Canico. Yep, absolutely. So we have a lot of ways to do some of these different builds, right? And actually creating the image. So with a tool like KBLD, we're going to look at how we can generate some of these builds through potentially different technologies, different providers, as it's probably going to be referred to, Docker, build packs, and otherwise. And And then, one of the big things that a lot of these tool sets, or the Carvel kind of tool set, I think does a really great job of, is making sure that we're referencing something that is reproducible, referencing something that is knowingly consistent when we redeploy it, move it around, and so on. And if you even kind of think about this for just a moment, right? We all know the old the tweets that come out that are like, never use latest. It's the worst thing you could ever do in the entire world, and people will be hurt if you do it. And it's a good piece of advice, right? Because you think about a tag like latest, and latest changes over time. So when something happens in an environment in one place, you have no idea what was latest, and also in this iteration of a cluster, what does latest actually represent, right? And if you kind of think about that for a moment, it's definitely way better to do something like 1.0.2, significantly better to do something like this. But what is this, right? It's a tag. So can I rewrite 1.0.0.2? Can I change the underlying image that gets represented in it, right? Am I guaranteed that it's going to be the same thing in most environments? Now, in almost all the cases that we probably run into, there's no doubt that using these tags is consistent, and people have really elegant pipelines in that they would never overwrite theoretically a tag, and so on and so forth. But what if we could take this a step further, especially when we have transitive dependencies of potentially other containers we care about that we're not even in control of, and have a way to actually look at the digest of the container image, so that we could guarantee based on effectively a hash that we are getting a consistent image in every environment, independent of what other people are doing, right? So you've probably seen this digest kind of format before, and we'll kind of look at it today. But imagine that this is some sort of hash value that we can point to, such that yeah, sure, it's not as clean as 1.0.2, but that doesn't matter to us, because what we're really trying to say, just like when we look at a Go mod file inside of a Golang repo, we want a way to guarantee consistency in our builds, consistency in this case, I guess, in our runtime even, right? So these are the kinds of concerns that we're going to be looking at with KBLD. And now maybe I'll shut up and we'll actually try to make it work. What do you say? So what do you think, chat? Does that make sense? And Noel says digest becomes a pain when doing multi-arch. Yeah, that's a good point. Yep, absolutely. So Noel, in your case, are you doing Windows and Linux? I'm assuming those or maybe you're just doing ARM and AMD or something like that. Cool. Let's see what we got going on here. So I am going to flip over to my terminal. Okay, and let's see if we can get this kind of bootstrapped. In fact, we'll actually go over one of the guides here in the docs. So we'll go to examples, and all right, where are my docs I was looking at earlier? Documentation, there it is. Cool. So this is all on the Carvel site, and if you want to check it out after this is done, feel free to check out the docs and all that good stuff. It talks a little bit about digest references. So these images, again, can be referenced from the name tag pair, which is probably what a lot of us are pretty used to using, or a digest like this that'll have the actual SHA in it. And again, like we were talking about, this kind of gets us closer to immutable land, where we have some amount of guarantee that this is going to be the exact image. And this enables us to use tools like this in a couple different ways. One is, maybe we don't even want to use KBLD to build our assets and our eventual images, but maybe we just want to use it to take existing manifests and convert, if you will, into that digest format, such that we can have some amount of guarantee that the thing is going to actually be a consistent experience across all the different places that we might be deploying to. So let's try this out real quick. Resolving image references to digest. This should probably be exactly what we talked about. So speaking of Ingress Nginx, since that's everyone's example, let's go ahead and start with just a quick example of this real quick and see if we can make it also validate that I have KBLD installed correctly. Okay, so let's try this out. Go to episodes 142. Great, and we will do the Nginx YAML file. There we go. All right, so we've got the image, we've got Nginx 1.4.2, and we know that this will resolve from Docker Hub, right? So let's go to Docker Hub real quick, and we will grab, just to take a quick look here at Nginx. All right, so tags. And we'll see if we can even find that tag real quick. So 114.2. 114.2. All right. 114.2. Okay. So here's our different digests for our different architectures. So to Noel's point, exactly. You're one thing that you're doing with the specificity here is you are narrowing in on an instance of the container based on the SHA, or I should say the instance of the image based on the SHA, but each one, there's going to be a unique one potentially for each architecture, right? Which is effectively what we can see right here, all right? So I'm on AMD 64. I'd expect it to probably resolve to this digest right here if all goes well. So let's go ahead and try that out. So KBLD, and let's see if there's I guess there's no command. It doesn't say what command I should run. Oh, there it is. Okay, cool. So let's go ahead and do that. So we've got KBLD on the machine. We'll do a quick version check. Cool. Then we'll do KBLD, and let's look at the help real quick. That'll probably be good. Okay, so KBLD is a command in and of itself. It has some subcommands, inspecting images, packaging them into a tarball, relocating images between two registries. So this will be an interesting use case that we'll look at today, including in the context of image pack, and unpackaging the tarball, of course, and then the version which we just saw. So let's go ahead and run this command, which was KBLD for the file, and we'll do nginx.yaml here. Okay, and I should have put that into a file, huh? So we'll do nginx 2. Oops, nginx2.yaml. Let's roll with that. Great. All right, so what happened to the manifest here? We've got some annotation information that got put in. So it looks like this is our way of saying, hey, this started out as tag 114.2. We resolved it against this URL. And then here is a specific URL that we grabbed from Docker Hub, right? And then if we go down to the image itself, we can see the actual full URL with the digest here. So SHA-256, F7988. And then let's see here. Okay. 295C. And it doesn't match. I wonder why. Am I looking at the wrong image? 114.2 F7. Okay, interesting. I don't know why that doesn't match. Dimitri says in the Nginx case, the tag actually points to the image index. Oh, okay, interesting. Got it. 295C. Okay. Cool. Well, nonetheless, we've got a specific hash right here that it's referencing. So we can have some amount of guarantee of which container that this is coming from, right? So that was kind of like a conversion piece. We kind of just did basically one piece of that bigger puzzle, okay? Now, what about actually taking it a step back and maybe like building out manifests themselves and actually running some type of build with a tool set like this, getting the digest, potentially pushing it to a repo and all that good stuff. Let's take a quick look at that. All right. So we'll back up a little bit and talk about building images. All right. Now, this is kind of an interesting one. So let's actually take this YAML file and just take a look at some of the fields here. We'll take a closer look. All right. So, okay. In fact, I'm going to do this in a Go project I have. And just get rid of some extra files here that used to have manifests in them. Yeah, okay, so call this deploy.yaml. Okay, cool. Let's take a quick look. So in this case, we've got a deployment manifest, right? And you'll notice that right now, this has a unresolved image ref, right? So what we're hoping to do here is be able to build some arbitrary project, right? And actually go in and potentially push the image and then replace this kind of placeholder with the digest. So you can think about this from like a build pipeline and how nice something like that can be. We run the build, the underlying piece uses Docker or maybe build packs, pushes to the repo, and then it stamps out this kind of immutable manifest, if you will, that again is representing the digest of the exact thing that we built. So let's see if we can make this work. Now this has 2 deployments in it, and I'm just going to go ahead and get rid of one of them. And we'll take a quick look at this config CRD, which I think has a bit of the magic in it. All right, so for the config CRD that we've got down here, we've got obviously the image name that we want to put in place, and we've got the path. Now, taking a look at some of these fields, I think there is, configuration for sources here. All right, let's look at the configuration for, what was this? Was it sources? Is that what I'm in right now? Sources, right, okay, cool. So for sources, we have, in our case, a image and a path field. So the image field, starting with that, I'm guessing this is just the name of the image, but I don't know if I see any docs on what that one is. Probably just the name of the image itself. And then the other one is path, which is, let's see, am I missing something in these docs? Path, okay, sources, path, image matcher, path is the source location. No, that's a different CRD, isn't it? Let's see. I think path is where it's gonna find my Docker file. I'm pretty sure that's the case. Specified path is source, pool, file. Oh, name of the Docker file is in file. Huh, interesting. Okay, we'll see if that works. Okay. Pack, config, path. Huh, okay. So we'll go into sources and into path. And in this case, I do have a Docker file right here. So let's just see if I can make this work. All right, so in this case, we have a Docker file for this little Go app. This Go app is something that I wrote the other day just to demonstrate something about file streaming. So it's nothing too crazy, but it basically just takes a CSV file and it does a buffered read and write to send it to a response body. So it's like an octet stream type thing. Nonetheless, it's just a little Go app, and then it has a Docker file that is being used to build it. So inside of the Docker file here, I'm definitely not doing what I should do if this was like a more serious thing, right? I'm using the Golang image, which has all the build tools and all that stuff. I should be eventually copying this into like a distroless image or maybe a Scratch image and doing all that. But just for the sake of simplicity, I copy and pasted this out of the Go docs for the Docker file. But nonetheless, this is a Docker file. It should be able to run. And we'll go ahead and go back here, quit out of here real quick. All right. Noel says well-formatted code. Yes, thank you. It's not a lot of code though, but it is well-formatted. It has comments. Okay, cool. So the path here, I messed around with this tool a little bit today, and I think path is referencing the Docker file, but someone in the Carvel team can tell me if I'm wrong. If For some reason, I can't find, I swear I saw it in docs today, but I can't figure out what this field actually means. Executing, sources configure KBLD to execute image building operations based on the path. All right, well, we'll see. We'll see if it works. And then the image, simple app. So again, the kind of matching resolution that I'm looking at here is that image here should ideally match image here. And I'm thinking, again, if it builds okay, sees the Docker file, understands to use a Docker provider, it should build it, and then we should get a digest in here, if you will. So let's just see if that works, and we can figure out if I did something terrible. So we'll do KBLD again. We'll do the file of, what did I call this thing? Deploy.yaml. Okay, started build using Docker. Docker should be running. So let's see real quick. Sudo system ctl status Docker. Okay, Docker's not running. So let's start Docker up. So it noticed that it needed Docker. That's good. So we've got that. We've got Docker running, which is great. And then we'll go ahead and run it again. All right. So starting the build using Docker. With the simple app here. All right. All right, so Dimitri says it's under the config CRD, and Aaron says the configuration doc explains the config schema. Let's see if I can find that while it's building. Configuration doc explains the config schema. Sources. Okay, so I was in sources, right? Sources inside of config, and then the definition of path. Where is that at? Docker CLI pack build kit. Pack towards the top. Okay. Path to source location. Okay, I'm guessing that this is what you're talking about then. So path to source location, source of the entire project. Cool. All right, so Docker is the default. So the fact that I didn't put Docker in, that we know why it detected that. Let's do a quick check on the build. Okay, so it looks like it's building, bringing some output from the Docker daemon. So like, yeah, again, the important thing to know again about like the scope of a tool like this is it's not like re-implementing another build system per se. It's leveraging build systems that are well established to do the job really well, to delegate this work to them, which is again kind of a beautiful thing about some of these Carvel tools is their scope. So, all right, so we have image, we have path, source location. We can use Docker or pack. Kubectl build kit uses the build kit CLI. Destinations. Okay, so destinations is probably what we're going to want to do next, everyone, because I'm obviously building locally. And my guess is that the digest that it puts in here is not going to be a real thing unless somehow my computer is all of a sudden hosting a publicly facing registry, right? So I'm guessing destinations will be one of our next things. And I'll probably be able to put in my own like Docker Hub URL. At least that's what I'm hoping. So we'll try that. Where do you see 20 gigs? Oh, wow. 20 gigabytes. I also, we'll see how long this takes. Let's see here. I think I built it earlier today too. Docker images, KBLD simple app. Yeah, there's that. All right, we'll let that build for a second. And while that's building, I'll actually open up a new window here. And let's go ahead and check out the file again here to make some changes. So to try to bring this full circle a little bit, we've got config, we've got the simple app bit. Let's go ahead and talk a bit about putting a destination in place. So destinations, and Carvel team, if I do something really silly here, just let me know because I'm mostly shooting from the hip. Destinations will be this. We've got the image, right, which we'll call the image itself. I'm guessing this will be interesting. I wonder what the image field means in this context, actually. image is an optional image matcher. So my intuition would be that this should also be simple app. We'll find out. And also I should probably do this real quick. Docker login. Okay, great. I'm logged into Docker. Okay, cool. So we've got simple app. We've got the path set. This is probably Dimitri. I'll put in my name now and we'll call this thing simple app. All right. So I've got the destination in place. Okay, new image and then tags. Tags to apply to the image. Let's put a tag in here, huh? So we'll do tags, which I'm guessing is an array. Do optional array of strings. Okay, cool. So our tags will be V. Whoa, caps lock. My caps lock, it has like a little light and it is choosing to have the light off when caps lock is on, but on when caps lock is off. That's confusing. Okay, let's do 1.0.0. How's that sound? All right. So we should be looking pretty good. Destinations, all that good stuff. I almost wonder if I should kill. Oh no, it succeeded. Great. Okay. Yeah, Vim and caps lock is a bad combo. It's amazing how much you can destroy when your caps lock is on, right? Okay, cool. So it did build. You can actually see the image digest as well. I think I had tmux like scrolling up so it wasn't actively showing more of the terminal. But let's take a quick look inside. So what did it do? Did it put, is there an output flag actually? I wonder if I was supposed to use an output flag. So deploy, okay, let's try this one more time. KBLD, hopefully it'll go really, really fast this time. And I wonder where it saved the YAML file. Let's see. Because it clearly outputted one. Oh yeah, it is my repo. Yeah, serving large files, because I was trying to explain how you could push like a 9 GB file with only using like a couple kilobytes of memory through buffering. So maybe I picked the worst example humanly possible. That could very much be it. Yeah. So let's see something real quick. Actually, check this out. We're gonna get rid of these two files. Lots of data. Okay. Now let's try. Look at that. That's a lot smaller. 1.454 megabytes. Okay, so this is better. Much better. Yeah, Noel says Docker ignore. I should throw a Docker ignore in there. I never intended on making this into a container image though, until just now. Okay, anyway, so this is the YAML file it printed out. I'm guessing that this is it, I don't know, Dimitri, is this saving it to a file somewhere? Am I missing it? Or is it just output there's probably a flag that I need to put, but let me just copy it real quick. Here, let's grab all this. So, boop, get all this. Okay, cool. So we will do a new, just standard out. Okay, fair enough. New YAML.YAML. How do you like that name? New YAML.YAML. Okay. Deployment. Cool. So what do we got this time in the metadata? So some information. And again, this is really just cool how it's got details about what's going on with the actual source repository. Again, it speaks to kind of the chain of integrity we now have in understanding source to image and then even resolving the image eventually downstream. So the URL is index.docker.io. And then obviously this is, this is my repo, right? So in theory, because I just did a rebuild, let's take a quick look. So I just did a rebuild on this deploy, right? And I had forgotten that I had changed this piece of it. So in theory, in Docker Hub, my repo probably has simple app inside of it. Let's validate that real quick. So we will go to Docker Hub. I will sign in to Docker Hub. Let me just grab my credentials here. Okay, what do we got in Docker Hub, Josh? My content. I haven't been in Docker Hub in so long. And it will show in a moment here when I literally don't know where to go. Hey, Simple App, check it out. All right, so we built Simple App, and we've got the tags here. This is an interesting thing, KBLD rand. Where does this tag come from? That's interesting. Is that just something that comes along with what I built? Maybe? I don't know. But there's v1.0.0. We can see the digest right there as well. So, yeah, Noel, I really dig the metadata too. I think just, again, carrying this all the way to the point where we deploy in Kubernetes and just being like, wow, I very, very concretely know the source, right? I concretely know the source, where it came from, and some context around it is really neat. I like that a lot. And John says, images built in Docker daemon are not assigned digest. That makes sense. Okay, so you got to make up the tag. I got it. Okay. Yeah, that makes so much sense. Cool. Yeah, that's pretty neat. So effectively, we've gone in and taken an arbitrary project with a massive build context, and we've been able to set up a manifest like this where the builds are actually reproducible. And we can pair a lot of this stuff up with, again, like the different tools in the tool chain. So if you go back to a previous TGIK where Joe explored YTT, we can use KBLD to handle some of this image resolution stuff for our various images, have it be consistently built. We can also have YTT going in and changing some of the different attributes out inside of here as well. And then all inside of our build pipelines, right? Or even in our local desktops, like in my case, we have a really easy way to create these consistent builds. So pretty cool. Yeah, I like it. What do y'all think? I think one other thing we can look at before we leave KBLD behind is there is the notion of relocation, which I'll just mention because we'll talk a little bit about this, I believe, with image pack when we get into that. But inside of here, there is the ability to actually go in and bring these different images between, I believe, just between either a new tar, if you will, that you could bring up and manually put somewhere, or actually go between different repositories, right? Which is pretty cool. So we'll explore that a little bit with image pack. But one of the commands you probably should at least be cognizant of and check out is some of these bits in the packaging and relocation docs as well. All right, so let's go ahead and swap on over to image package. All right, cool. So we've been on this kind of thought process around immutability, around consistency, around integrity. And that's good. And it's gotten us pretty far. But what about the idea of the assets that aren't just container images, right? Like think about what Kubernetes has sort of become for a moment. We go in and we deploy these applications like Istio or Knative or database operator of some sort. And we basically have 500 lines of YAML that describe all the different things declaratively. And it's great. We just apply that YAML to the cluster, and then through reconciliation, a bunch of stuff happens to make it exist, right? But when we think about the process of packaging stuff that we want to be able to consistently deliver, what if we want to be able to provide a similar guarantee for all of the different pieces of the puzzle here? Not just the container images, but the manifests, the ancillary files, and all that different kind of stuff. And taking that a step further, we know that there has been kind of the proliferation of registries that support OCI compliant bundles in general. So you might remember this progression when things like, who was the first one that got to it? Was it Harbor or was it Quay? I can't remember, but one of the two were the first to kind of say, hey, we're going to let you bring your Helm charts up into the repo and other OCI compliant assets as well. And this is something that Harbor does today. So we've got these OCI compliant registries. And basically, if we think about these as not just specific to container images, but kind of bundles in general, we can create these packages of all the contents. We can put them up in these repos and then pull them down in a way that we can, again, guarantee the kind of integrity of the asset we're bringing down. So that's what we're going to be kind of taking a look at with Image Pack. And this is one that I'm really particularly excited about. So Image Pack we're going to be looking at in the context of Kubernetes, of course, but it's kind of like a very generic thing. Like, it's going to let us bring arbitrary files together, package them up and kind of create this OCI compliant bundle. And like, you think about what's a use case where this makes sense. So Josh, that all sounds neat, but like, why would I ever care? And I think this middle box is a great example, one of many of why this is nice. So being able to take in air-gapped environments, if any of you work in like the federal space or the financial services space, you probably are familiar with the pain and agony that is the inability to just go out to Docker Hub whenever you want to. Like some of us, like myself, who just screws around with random things all day, right? I can just go grab any old image I want to, right? But in a lot of our environments, they're super locked down, and it requires us to kind of bring all the different assets into a location, be it an internal registry or even just like, I've had a lot of times where I've had to like load tars manually into the Docker daemon to make them work in someone's environment, right? Not manually with a script, but it might as well have been manually. So this gives us the ability to create these bundles again with all the different assets and then bring them into, be it probably just a tar file, but also bring them into like registries that exist inside of our environment, right? And kind of going back to that example I gave with GoMod, we have the lock files that are going to ensure that we have the same image versions that are going to be used across. So like you think about like GoMod and all these different things that do similar processes of keeping these lock files to ensure integrity of the images we reference and all that good stuff. So let's see if we can do a little bit with image package now. So, cool. So image package, set of arbitrary files into an OCI image. That's what we have. That's what we have figured out. Noel, you said true releases is hundreds of gig tarball. Yeah, it can be big. Image Pack's primary concept is a bundle, so that's what we'll be looking at today, which is an OCI image that holds 0 or more arbitrary files and then references the OCI images. So again, this is kind of where that I think this is where that lock file and stuff comes into play, where we actually have the ability to go in and reference other things consistently. And you can kind of see where the story's playing out here. If you take a step back, it's like you have the SHA integrity of the bundle, and then you have the references to the OCI images that you can also guarantee on that level as well. So we can actually, again, build this package, have not only the bundle itself be consistent, but ensure that the references it makes are consistent as well. All right, so let's check out the basic workflow and the air-gapped workflow, and we'll take a look from there. All right. So basic workflow, creating a bundle. All right, prepare the bundle contents. So we'll see if I can work with my existing repo here. If not, we'll go to this basic example here. Has a config YAML, which contains very simple Kubernetes application. Yep, we've got that. So in our case, I think what we're going to end up pointing to is going to be new, or I guess what we're going to care about initially is going to be new YAML.yaml, because this is the output from standard out that I did copy. I probably should just make sure real quick. Kubectl apply new YAML, just make sure. Okay, cool. I have no idea if the app will run successfully in Kubernetes, but at least I know that the schema is right from a Kubernetes standpoint. Let's see real quick. I'm kind of curious. I'm pretty sure that this is going to blow up for some arbitrary reason, but we'll see. Okay, so we've got that in place. And we're going to add this image package directory. Okay. which will have the optional bundle YAML, which records informational metadata, and then the images YAML, which records the image references used by the configuration. Okay, so this will be kind of interesting. Let's see if we can build this out here together. So we'll go in and go ahead and make the image package directory inside of here. All right, image package. And then the bundle YAML, and then the images YAML. So let's check this out real quick. Bundles YAML. Okay, so this is the bundle itself. File contains bundle configuration, contains details about the bundle's authors, associated website, all that good stuff. So let's just copy an example out of here. This appears to be metadata. So bundle, oops, let's make sure it's in the right place though, right? Image package, bundle YAML. Okay, cool. Let's do that. So we've got the bundle. This will be TGI Rocks bundle. Full name will be Josh. Okay, and then we'll keep the rest as is. Okay, so we've got the bundle metadata in place. And next up, we need the actual images YAML. So is this the lock file? Required contains image lock configuration. Okay, image lock configuration, good. API, images lock, images, blah, blah, blah. Okay, this seems good. So let's see if we can grab this image lock file out of here and put it inside as well. All right, so we've got bundle YAML. Let's go ahead and put images.yaml inside of here. Okay, so images, image lock. All right, so I'm gonna come back to this in a second as we get deeper into image package, but we've got image package, we've got the bundle, we've got the images. Note that image package images contains a list of images, each with fully resolved digest references and a little bit of additional metadata. Okay, this allows us to record the exact image that will be used in the Kubernetes config, and would be created either manually or in an automated way. We recommend using KBLD to generate that, which is exactly what we to generate the images.yaml. I see. We should have done that. Silly us. So this is, obviously we can create it manually, and we probably could reference the image that we want, but we're using KBLD to build, so why would I not put the images file in through KBLD? Let's see if we can do that. So we'll back up. And again, this is kind of the great thing about tools that are designed this way, is that they can be single purpose. They don't have to solve the world's problems, yet they can pipe together in ways that make us, and that enable us to build really effective workflows, right? So John says you still can rerun the lock with the lock file flag. That's what I'm thinking, John. So I'm gonna do exactly that. Did I call it config.yaml? What the heck I call it deploy.yaml. Yeah, some of you who haven't seen me on TGIK before, if you haven't, you should know that I am a master at naming things extremely poorly, like in the most confusing way you could possibly think. I mean, if you think about it for a moment, like let's just humor me real quick. Let's go into serving large files. I named this file newyaml.yaml. So if anyone needs any advice on naming, you just let me know, okay? So KBLD deploy YAML, image package lock output images.yaml. Let's do it. Error checking file deploy.yaml, because I weirdly put A's in my YAML files. All right, let's do this again. 1.458 megabytes. It will push it up, and this should basically redo the tag inside of Docker Hub as well. Let's see here. Give me just a sec. Come on. Okay, cool. So we'll go back to the bundle, and we've got that output here. We've got the index, okay. Again, because I'm just worried about losing this, I'm just going to save it for later. We'll call this newer YAML.yaml. Newer YAML.yaml. We'll put this here just for the sake of reference. All right, and then let's see if the file now exists inside of the image pack directory. So if we go into image package, we go into the images YAML. And there it is. Sweet. So the image lock file got created by Kbuild, which is cool. So put that inside of there. It's got the actual reference. This is effectively our lock file. And then we'll go back to our example here. All right. Pushing the bundle to a registry. Authenticate with a registry where we will push our bundle. Okay. Okay, so I should be authenticated because I did Docker login. That seems fine. Push the bundle to the registry. Image package push, the name of my bundle, examples. Okay, so this will be the directory with the files. What do y'all have in your basic step 2? Is it just the manifest essentially? Let me see real quick. Just want to see what are all the assets. So image package is obviously there. Config YAML is there. Okay, and this is then the deployment itself. Interesting. Okay, cool. So that makes sense. .image package, images. Okay, cool. The image, okay, so like in this example, it looks like Dimitri's got the resolution working through the actual digest, which is this. And then is this basically like a selector? So if we have Dimitri Kate's simple app, then go back to the config YAML. Yeah, I'm guessing so, right? Is that kind of working like a selector? It seems like it. So it's probably going to use the image lock to swap that out, I'm guessing. I guess we'll see in mine. So we've got this right here. We'll save that up. We will back up real quick. Now, I guess the structure here is pretty important because it probably wouldn't be a good idea to bundle all these files, although I could, right? But it probably would be smarter for me to have another directory here. So like manifest, I guess. It's also, again, not a good name, but you already know this about me. So if I go into the deploy YAML file and the image pack file, and I put this into manifest. Okay, great. So manifest inside of here, deploy YAML image pack. And John says those strings will match and replace the unresolved reference with the resolved one. Think of that lock file as a mapping from a string to a resolved reference. Perfect. That's exactly what we need. So we've got deploy YAML, we've got image pack in here, and it's probably, you can tell me if I'm wrong here, John, but I wonder if this should be in a separate file. That would be my intuition. If it's going to resolve simple app. Let's look at the lock file real quick. Image package, images. So there's my selector, simple app, right? It just feels weird to me to have this config in here, but maybe I'm overthinking it. We'll see. So we'll do config.yaml here and put this in place. Oops. Yeah, that one. All right, config.yaml. Seems good. We'll resolve that. All right, we've got this manifest directory now inside of my repo. And again, this has the .image package, it has the config, it has the deploy, it has all these different bits that we need. All right, so I think we're looking pretty good. Let's go ahead and try to run this thing. So going back to image package, where was I at before I started screwing around with everything? So Kbuild made our lock file. That's fantastic. We authenticated with a registry already. We're going to push the bundle to the registry. That's where we were. So B is the location of the bundle for the OCI registry. Okay, so this is probably where it's going to be in Docker Hub, I guess. In my case, in Docker Hub. The second one is the file, which is the actual contents to include. So remember, backing up a step, we are not sending the image up here. We are sending the package of the assets that are the manifest in our case, right? And then that will, again, have references to the images, which can be a completely different OCI repo and all that good stuff. Cool. And John said, because config is not a resource, it's a good idea to have them in separate files for humans. Okay, but they don't have to be in a separate file. So maybe just best practice from a cleanliness standpoint, but I might not have had to separate these per se. All right, sweet. So let's go back and get this thing pushed up. All right, so image pack push B. Okay, so mine's gonna be image package. Here, let's clear this out. Image package push B. And in my case, it is going to be this. Oh, cool, simple app bundle. So we'll keep that consistent. So we'll go back here. We'll put this in place. Obviously, I am not user one, as rad as that username is. And my file, as y'all know, is inside of manifest. So I think this is our command. Pretty sure. Noel said split and tabby, learn something new in Vim. Hey, I'm here to help, Noel. If not in Kubernetes, at least in Vim. Okay, image package push. Let's see if this works. Dir image package bundle, config deploy, deploy.yaml. And now we have pushed this bundle into Docker Hub. So let's go ahead and check this out. So we'll go over to Docker Hub, which is right here. We'll go back over to my repo, maybe repositories. And there it is. Simple app bundle. Okay. Now, let's take like another step back here and kind of think about what is really interesting about this model. We've kind of achieved, to a degree, something that looks a lot more like package management. If you kind of think about that for a moment, like how I liken this is, you know, as let's do something. Arch user repository. Okay, let's take a quick look, and I'm gonna do something very, I don't know if you call it meta here. I'm probably mostly just wasting your time at this point. But if we grab what something looks like from kind of a package management standpoint for just a moment. So I'm going to go into a temp directory. I am going to, let's see if I have anything Carvel related here already. No, I don't. Okay, cool. So we will grab in from what is a user package management. So think of this like if you use Aptitude with Ubuntu, think of this like one of the user repositories in a way, right? So a lot of times we basically have these things inside of here, right, that tell us how to, they're kind of like a descriptor of how we're going to go out and how we're going to get all of the different things. And this is kind of like versioned and packaged, and we can go out from a package management standpoint and get this metadata and these assets to sort of understand how to download and install the thing. And in this case, this is how one could go in and install the Carvel toolset if you're running this specific distribution. And then you've got all of the different SHA checksums, which are effectively pointers to the binary for the architecture that you're using in this case. And why I bring this up is it's just really, really interesting how what's old is kind of becoming new again, and how this can really, like some of the cool thing about KBLD and image package to me is that, like, at first when I kind of heard about it and started to understand it, I kind of thought like, it's interesting, but I don't really grok like what models it's unlocking. And I think if you really kind of think about it for a moment, this integrity, this ability to bundle these different assets up could enable us to unlock some really interesting models in Kubernetes that work a lot more like the package management systems that we've used for years and years and years. And I just think that's like a really interesting thought to kind of ponder as some of you explore some of these tool sets. But aside from that, like random thought process there, yeah, I mean, this is really cool. We've got our app bundle in place. It's in an OCI repository, which is Docker Hub in this case. And Otama, you said package build is similar to the old BSD way. Exactly, right. So what's old is new again from what was also old in the past as well, right? So it's just a super, super interesting thing. And I don't know, like Kubernetes is kind of becoming boring in ways, but like this is, I think, is an area of Kubernetes that's like really interesting and potentially ready for some cool innovation, right? So yeah, we've got simple app bundle, we've got simple app. I'll see if there's anything else it recommends. Pooling the bundle to the registry, image package pool. Yeah, let's use the pooled bundled contents. Okay, cool. So you can see here, right, we've got the ability once again to kind of pipe some of these things through. So KBLD we can take the assets that come out of it. We can kubectl apply it, of course. In fact, let's just look at that real quick. Let's see if I can do a quick pool. So pool is probably the exact same thing, and then I just tell it where to go, right? All right, let's try that real quick. So we did this command here. Instead, we'll do pool. Okay, and then let's just go ahead and put this into temp. I don't know where to put it. Where should we put it? Makedir temp TGIK. Okay, so great. All right, let's pull this guy in, and then I wonder if is it going to put like the locating lock files, one or more images not found in bundle repo, skipping lock file updates. Okay, let's see if I can find this real quick. So temp TGIK. Cool. So there are our files effectively. And if we look at the deploy.yaml, we can see simple app is inside of there. And then I'm guessing, let's see here. So it's put in, would I run KBLD again to put in the config? Yeah, that's exactly it. So KBLD would run against the config. So let's do that real quick. So KBLD, yeah, because this, okay, sorry, I'm learning and thinking at the same time and kind of rambling here, but you can probably see what's going on. So config YAML is inside of here, right? The image package is of course inside of here because this is going to contain the lock file. So once this asset comes down, once we pool this bundled, hashed, asset, we can then go in and basically do similar things to what we were doing before. Now this time, we of course don't need to build the actual application, right? We just need to basically build the, or I don't even want to call it build. We need to parse or render the manifest, right? So if we do KBLD again, and the file in this case will be my config YAML, and then I need to reference, oh, interesting. So I'm surprised it doesn't look for this file automatically. But I guess maybe it's just not a convention thing. I don't know. Images, what is my image lock file called? Images, yeah. Images, YAML, okay, config. No IntelliJ, go away. I don't have a license for you. Intentionally, go away. Okay, so that's good. This seems good. And then we should just get our manifest. Where did it go? Does it have an output flag? Interesting. So I can pipe it through kubectl. What am I doing wrong here? -f deploy. Oh, duh. Yeah, thank you. Thanks, Dimitri. As long as someone's paying attention. It does tell me it succeeded when the file didn't exist. So maybe that's something we should look into. But there we go. Cool. So containers, we've got the hash. Seems pretty good. Yeah, this is super cool. And again, like I know I'm probably kind of a broken record at this point, but it's sweet to see tools do one thing well and then have like these different contexts that they can be used in. Because remember, like we started off with kbuild, building out like an entire image and then pushing it up, giving us the digest, creating the image lock file. And now we're just in a place where like as kind of like a downstream consumer, like think about it. Maybe I'm the person who just worries about getting the app into the cluster, and I'm not concerned about the build process that happens before. Well, now I'm not like figuring out the 14,000 different places with the relevant tags and all that junk of where to get the thing. Like this is it. This is the immutable unit of the descriptor that tells me how to deploy the freaking thing. It's not that complicated. And then the beauty of it is we were able to again do this pull command here. In which I was able to bring it down, right? And then once it got brought down, I was able to come inside of here and basically say, hey, go ahead and do this deploy file. Make sure you look at the image lock file, and then that is the asset. It is, true, unless we theoretically go in and do something like this, image package. Where are you? Where am I? No such directory. They must have had the old one. Image package. There we go. Unless I go in and do something like this, which why the heck would I ever do it, right? We're good. Like this is consistent through and through, right? So that's the only way that I could really screw up this process from this perspective, right? Hey, Steve, glad to see you. We are making some immutable Kubernetes packages and images right now. So you're we're making them immutable. So very, very cool. Dimitri said config YAML also existed. There just wasn't any resources that weren't. Exactly. That makes sense, Dimitri. And that's probably what John was saying too earlier. Like from a human standpoint, like you probably want these separate. But in theory, if I had done this, I'm sure KBLD is smart enough to know that this is not the actual Kubernetes manifest, right? In fact, we saw that earlier, but I'll just tease it out anyways. If we go to deploy, we'll do this real quick. If we go to deploy here and we bring this back in where it used to be, okay, we'll paste that in, get that out, we'll put the config in, we'll save it on up, right? It's still gonna work just fine. So KBLD deploy, it still pops out just like that, right? Because it understands what that CRD is. It knows that it's, I don't know, what would you call config? Like a descriptor to instruct KBLD on what it should do or something like that, I suppose. So all in all, that's pretty good. All right. This is pretty sweet. I'm pretty close to being out of time here, but let's take a quick look at the air gap stuff and see if there's anything that I should call out here. Like you could probably imagine, just based on what we've seen so far, how we can enable this air gap workflow. But let's maybe end the day on this and take just a quick look at some of the air gapped capabilities. Yeah, Steve, we did talk a little bit about Flux earlier. Okay, so finding bundle in source registry. Okay, so we've already pushed to a source registry. We know that. Then there's two methods of copying the bundle, right? Option one, from a common location connected to both registries, more efficient because the changed image layers will be transferred to different registries. Option two, with an intermediate tarball. Maybe we should do the intermediate tarball. So basically thinking like, in the scenario that I had told you about, which I've had in a couple financial services examples where like, we don't have a registry, figure out how to get our images in here. And it's like, okay, well, I guess I will tar them all up and then load them into your container runtime. Thank you for making me hate my life. So we'll try that out. From location to both registries. So this is what I was kind of talking about, by the way. I think, Carvel team, you can tell me if this is a stupid statement, but when I was talking a bit about, K-build and like what was it called? Relocate or whatever. Like in a way, this is kind of sort of similar, I think, in the sense that like this is going to go from one repo to another repo with the bundle. And then will this also move the container images? I'm guessing so. The bundle, or will this just move the bundle actually? Oh, I'm trying to think that through. So if I do image package copy, is it just bringing the bundle over? Because if I'm in an air-gapped environment, wouldn't the references still look at the not internal repo? Huh. Anyways, we'll check it out, or someone in chat will answer. Okay, so let's do the intermediate tarball just to understand this. Actually, the intermediate tarball will tell us the answer. So we'll do an image package copy of our bundle, and we're going to tar it onto our machine here. So get the location of the source repo, blah, blah, blah. Okay, cool. Yeah, I wish this thing existed a year ago. I could have used it really badly. So we'll go ahead and copy it down. This is going to be my Docker Hub repo, right? And we're going to do it to a tar, which is TMP. We'll keep on going with this theme, TGIK. All right, let's see if we can copy this down. So my simple app bundle v1, exporting two images. Oh, it's a directory. You probably don't like that too much, do you? So let's go ahead and say bundle.tar, I'm guessing. Will that work? Let's see. Okay, exporting two images. Let's see if I can tell right from, oh, it is. Okay, it is copying the image, yes. So check this out. We did a copy, and it's basically being like, hey, cool. So you've got the bundle. I understand that. But also, I understand that in the bundle, you need the image itself, right? So you can see right here, this is the container image that it referenced, right? So we think about that relationship. It's like the lock file went over and pointed to the image. It resolved that. It knew it needed the image, and it appears it brought that down into the tarball as well. So if we do, is it tar gz? It's probably tar gz. Is it gzipped? Let's see. To tar. No, it's just tar. Okay, cool. Cool. So transfer the tarball to the location, destination, authenticate, import your bundle from your tarball to the destination repo. Okay, I see what it's doing there. Yep. Pulling the bundle from the destination repo. Okay, cool. So in short, we were able to actually kind of move this over to an entirely different place. Again, the beauty here is kind of like the resolution. It's like, let's visualize this real quick, because it's in my head, but I don't know if it's clicking with everybody. So like we think about the idea of like the descriptor, right? Or actually, you know what we should do? Instead of Josh doing terrible diagramming, let's do this real quick. About image package. Perfect. Let's grab this. Okay, we'll riff on this a little bit, right? All right, so this is a good overview too of kind of like what we talked about today. So the images YAML file, that's the lock file. It went out and it knows what the images are, and it knows them again from their digest, not just their tag. So in bringing this bundle local, or locally kind of bringing it in, we're actually taking these different, these little OCI images, and we're basically copying all of these as well. So basically these I should put copied in here, copied, right? So by kind of understanding that resolution, we were able to take this and bring it down locally into this repo, including the bundle itself. So this gives us a lot of ability to kind of move things between repositories, do air-gapped use cases, all of that good stuff. So, you know, one thing that we probably could do pretty easily, let's go back to this B command that we were doing before. So we'll do this, and let's just like, I don't know, let's do a destination that's slightly different. So we'll go into image package and we'll grab the air-gapped workflow. So to go repo to repo, let's see what this looks like. B and then the to repo flag. Okay, cool. So I'm guessing it's cool if I just do a different, name for Docker Hub, right? So instead of to tar, we'll do this, and we'll call this, here, let me break this down so it's easier for y'all to read. We'll do this here, simple app bundle. Okay, got that, good. Simple app bundle, we'll call this complicated app bundle. Okay, and let's run that. Image copy does not accept extra arguments. What did I screw up? Oh, I didn't put the flag in. Let's do that real quick. So this is the, what was it, to repo? There it is. All right, so in theory here, we're able to, building import repository. Repository can only contain the ruins. Oh, the ruins. It's always the ruins. What the heck? Oh, duh, that's why. Those silly Go runes. Always getting me, I'll tell you. Does anyone else hate that it's called runes? I feel like every time I read documentation and it mentions a rune, I'm just like, what is that? It sounds like something from Lord of the Rings. All right. Steve said, has YouTube removed using @ I don't know, Steve. I hope not. Let me see if I can @ you. I can still @ you. Unless it's just because I have very fancy permissions. I don't know. All right. Lord of the Ruins. Yeah, exactly, Ben. It's just like, it's Rune always strikes me so weird. I don't know why. Okay, cool. So we've imported 2 images. Now, oh, this will be interesting for us to check out actually, since we've gone repo to repo. If we go back to Docker Hub. All right, let's see if we can find complicated app real quick. Okay, so complicated app bundle. Okay, Carvel team, help me out here. What are the contents then? I see. Okay, so this is interesting. Let's take a step back. So what we had set up initially when we were first building everything up is we had simple app, which you might remember I used kbuild to actually build the image and push it to Docker Hub. And then we just pushed the bundle up, right? And the bundle was obviously the metadata content, the lock file, all that good stuff. And you'll notice the bundle is like this tag, right? That has, obviously can be referenced through digest, but it's just this that then has references to the OCI image. It looks a little bit more like this. Now, when we copied it, it would appear that what it did, and I don't know if there's a flag to let you like separate the repos if you want to. This actually probably is a more elegant model, but it put it all inside of one location. And what it did is it now has tags for the image, which is what you can see as this 300 megabyte piece, and then the actual bundle itself. So it's all self-contained when copied over here in this one location. Noel, you said, how can we enforce the deployments to use a bundled image? Some hackery with OPA. Yeah, I think, Noel, if I'm understanding your question right, that would be my intuition too. I think you'd probably need to do something at the admission control level that ensures. I guess I'd be curious. Like, what are you checking for exactly? Like, maybe you're checking to make sure that the deployment manifest specifies a digest rather than a tag. If that's kind of what you're looking for. That would be probably something that you could do. But yeah, I think I might be misunderstanding your question a bit, but based on just the gist of it, it probably needs to happen at the admission control layer, which could be OPA or, something you write as well. So yeah, this is super interesting. Now, just to bring the last piece full circle here, everyone, and then I told you I was only gonna stay on till 2 p.m. Pacific time. We're a little over, but I don't want to waste too much time. So let's go ahead and, I never stay on time during these anyway, so it's old news, right? Let's go ahead and just pull this down then, okay? So we've got, all right, so we've got pool, all right? And I'm gonna do a new directory here just so we're a little bit cleaned up. And we're gonna call this the complicated directory, right? And this time we're gonna bring down the complicated app bundle, bundle, right? Just so we can kind of see all of this come together, all right? Locating image succeeded. Good, okay? So inside of here, if I go into complicated, there we go. All right, so in the top, we've got complicated. In the bottom, we've got simple or TGIK, but these are basically our two, right? And if we look inside of the config YAML file or actually I should say the image lock file. So image package, images YAML, right? And then if we look inside of the image package for the image lock file again, now we can see the difference here. So the copied one knows that the image digest comes from this location here. It comes from the same bundle repo thingy in container registries, whatever the heck this part of the URI represents, right? And it knows to reference that SHA A0C7, which should be this right here, A0C7, right? Which is the actual image itself. But then, of course, what we pulled down as the bundle was the 7C833. Whereas this one here, Simple App, right? Simple App was built by us, and it is in a completely different repo. So the Simple App bundle, we pulled this bundle down, but in reality, it's referencing not the Simple App bundle repo, but just the Simple App repo, again, which is what the beauty of these lock files here is they can reference anything arbitrarily. And that's about it. So this is pretty cool. I guess maybe to kind of wrap it up here, everyone, what we kind of took a look at today is this idea of being able to we started from like the ground level, right? Of how can we create consistent builds and references for resolution to our deployments and their images. Effectively, like how can we make this immutable? How can we make this consistent, ensure integrity? And I'm using the word integrity kind of loosely there, so don't read too much into what I mean by integrity as much as just making sure the file contents are consistent, right? And then we took that a step further and said, okay, like that's neat. can we do something similar and create these larger packages that kind of understand all the Kubernetes bits? They understand the references to those OCI images that we've now made immutable, and then just kind of create this truly immutable system. And then as I kind of, projected or postured about for a little bit, how in this format, we can enable really, really interesting models around package management and specifically consistency in our package management as we get super complex in the different images that we depend on. And then perhaps, we don't just want to we want to make sure in our environments where it's really important that things are consistent, that when we pull images, kind of like what we do with GoMod, right? You think about GoMod, and we look at all these external things that we're referencing. We want to make sure that whenever we build, the SHA that it references is consistent and will not change. And that's something that we can do with a tool like that, which obviously sometimes we vendor everything locally into the repo to be extra sure. But it does show how this model can, again, create consistency across all of these packages and dependencies. And that's all I got for today. So I hope you all really enjoyed this. This was super cool. And I think we should do one more where we try to bring all the pieces together. So as a reminder, there is a new dev site up for Carvel. Check it out. I'm sure I should know this, and I'm sorry I don't, but I'm sure there's a Kubernetes Slack channel. Someone in the Carvel team could probably say it. I'm sure it's #Carvel, probably, maybe, but correct me if I'm wrong, team. But nonetheless, with what Joe covered with YTT and CAP, and now what we've looked at with kbuild and image package, I think what would be really, really slick is at some point in the future, we'll come back to this topic and we'll bring CAP controller into the picture, which is something that actually runs inside of the cluster, kind of like some of you who are used to Flux and stuff like that, and is another kind of independent piece that can go out and, theoretically, eventually get these packages, bring them in, reconcile them, and deploy them. And I think we can show the whole end-to-end picture when we cover CAP controller, since that, in my mind at least, is kind of like the final step overall. But with that being said, everyone, thanks so much for joining today. This was super awesome. I hope you learned something about kbuild and image package. I definitely did. It was super fun and super interesting to dive into this. As a reminder, we do these TGIKs at Friday at 1 p.m. So we should be back very, very soon exploring new topics. Might be myself, Paul, Tiffany, Joe. We'll let you know as soon as possible on Twitter when the next episode is. But until then, everyone, I hope you have an awesome weekend, and we'll see you next time. Bye, everyone.